Good morning, everyone. Today we're going to talk about some special situations when we're trying to solve for one variable. I'm going to start you out with two examples. The very first one, because it'll make more sense once we see an example. Let's say we start out with this equation right here. We've got x plus 7 is equal to x plus 1. Well, I recognize right away that I've got an x on either side, so I'm going to get rid of x on both sides, because anything I do to one side, I have to do to both of them. So let's see, those x's cancel and these x's cancel, so I'll get 7 equals 1. Well, wait a second. It seems like I must have done something wrong, because no matter what, 7 doesn't equal 1. By the way, there are some really special cases in calculus, if you get to that level, that you'll see that 7 can equal 1, but for our level, we're not in calculus. 7 can't equal 1. So let's say that, okay, maybe I made some kind of a mistake right here. Instead, I'm going to start over. And I'm going to say this time that, okay, I've got x plus 7 again equals x plus 1. Well, I notice I've got two regular integers, two regular numbers right here. So I'm going to get rid of the 1 to give myself x plus 6 equals x. Now I've got two options. Either I can ask myself what number is equal to that number plus itself, or I can get rid of this 6 that I have on, this x that I have on either side. So I'll get rid of that x by subtracting x and the other x the same way. And I'll get, let's see, x plus 6 minus x is just 6. X minus x is 0. Wait a second. 6 can't be equal to 0. Now, both of these situations, this where I first started by subtracting x from either side and got to 7 equals 1, and the other time when I got 6 equals 0 for the same equation, there's a reason that I got to this nonsense answer where 6 doesn't equal 0, so that's got to be wrong, and where 7 doesn't equal 1, so that's got to be wrong too. The reason for that is the equation that I started with. This x plus 7, this x plus 7 equals x plus 1. There is no number that x can equal where this is going to make sense. No number in the world that's going to satisfy that. That's what, because like if I said x was 1, I'd get 1 plus 7 is 8, and 1 plus 2 is 1, so it can't be 1. No matter what number you put in, it's not going to work. They're not going to come out equal. So the answer to this one is a great big no solution. It means there's no answer where it makes sense. No matter what, I'm going to get one number on the left side and a different number on the right. So now let's talk about a different situation. Let's say we start out with this equation. 2 times the quantity of x plus 1 is equal to 2x plus 2. Well, I'm going to choose to distribute this 2. I'm going to use the distributive property and say, all right, 2 times x is 2x plus 2 times 1 is 2 is equal to x plus 2. At first, this looks similar to our no solution problem, but it's different. You're going to see why in a moment. I'm going to subtract 2 from both sides, and I'll get 2x equals 2x. I'll divide both sides by 2 to get x by itself, and I'll get x equals x. Well, let's see. X equals x. What does that really tell me? I could say that x is 5, and let's see, if x is 5, then I'd put 5 here and 5 there, and I'd get 5 equals 5. If I say x is 3, I'll put 3 here and 3 there and say 3 equals 3. No matter what number I replace x with, that's going to be true. So this one is what we call infinite solutions. So whenever we get an answer like x equals x, we know it's an infinite solution. If theoretically, if I'd solved this same problem differently, I might have instead gotten 2 equals 2, 1 equals 1, or 0 equals 0. All of those would be an answer of infinite solutions. Whenever the end of the problem comes to either x equals x or a number equals itself, then I know I have infinite solutions. So now we're going to look at a graphic organizer that's going to help you keep track. And it's a sort of a cheat sheet, so you can know right away, once you get the last line of your problem, whether you've got infinite solutions, 0 solutions, or potentially 1 solution. So take a look at this graphic organizer right here. If I have number equals number for the last line of my answer, for example, 7 equals 7 or -3 equals -3, that kind of thing, I know my final answer is infinite solutions. The same for 0 equals 0 and x equals x. Any of these three right here mean infinite solutions. Now, if on the other hand I have some number equals not the same number, like if my final line of my answer is -7 equals 3, or 2 equals 5, or anything like that, or if I have 0 equals anything but 0, my final answer is no solution. There's no possible value for x that's going to solve that problem. And finally, if I have one that comes out regular, like most of the ones we've been doing, where I might say x equals some number, like x equals 3, that's a case where it's just one solution. Now let's look at 2 more examples of infinite solutions and no solutions just to completely solidify your understanding. So let's say I've got a rather tough one. Let's say I'm looking at 1/3 of 6x plus 3 plus 5 is equal to 1/2 of 4x plus 8. I have 2 options at this point. I can either figure out the lowest common denominator between 1/2 and 1/3 and multiply times that, or I can do a 2-step approach, which is the same thing in the end, which is what I'm going to do because it's a little bit easier. The numbers of it are easier. So let's say I'm going to start by getting rid of this 1/3 over here. What's a number I can multiply times to get rid of a third? How about 3? So I'm going to multiply everything in this times 3. I'm going to multiply this 1/3 times 6x plus 3 times 3. I'm going to multiply the plus 5 times 3. And I'm going to multiply this 1/2 times the quantity of 4x plus 8 times 3. So in the end, those two 3's cancel, and I'm left with 6x plus 3 plus 3 times 5 is 15 equals, and then 3 times 1/2 is just 3/2. So 3/2 times 4x plus 8. Now, next I see some like terms I can combine. I'm going to say 3 and 15 to go together, so I'll say 6x plus 18 is equal to 3/2 times the quantity of 4x plus 8. Alright, I'm most of the way there. But I'd like to get rid of this over 2 here. There's a way I could get rid of the whole 3 over 2, but it would be way more complicated. Instead, I'm just going to get rid of the denominator and turn it into a whole number. And the way I'm going to do that is I'm going to multiply both sides times 2. So let's see, 6x times 2 is 12x. 18 times 2 is 36, so I've got plus 36 equals that 3 over 2, the 2's cancel, so I'm left with 3 times the quantity of 4x plus 8. Now let's see. 3 times 4x is 12x. 3 times 8 is 24. So now I have 12x plus 36 equals 12x plus 24. Oh, and hey, thankfully I can quickly get rid of this 12x over here. So I'm going to say minus 12x to get rid of that 12x. And I'll say minus this 12x to get rid of that one. And I'll be left with 36 equals 24. Well, that makes no sense. Well, I don't know. Maybe there's one more step I could do. Like maybe there's some kind of a common denominator I could divide both by, and maybe that'll help me. I noticed they both divide by 12. So let's see, 36 over 12 is 3, and 24 over 12 is 2. But wait a second. 3 equals 2 still makes no sense. 3 doesn't equal 2, does it? No, it doesn't. And if I look at my handy-dandy chart that I made, I'll notice this is a case of, let's see, oh, number equals not same number. Yeah, this 3 equals 2 right here, that means my final answer is not 3 equals 2. My answer is no sol. That is an abbreviation meaning no solution.